convert a single-gang nail-up switch box to a two-gang configuration in an existing drywall application, several methods can be employed with minimal damage. Firstly, consider a wall plate extender. This involves purchasing a plastic frame designed to fit around the existing single-gang nail-up box. Next, carefully cut a piece of drywall to fill the gap created between the extender and the surrounding wall. Ensure the drywall patch is flush with the existing wall surface to create a seamless transition. Use drywall screws to secure the patch in place, and then apply spackle to smooth out any imperfections or gaps. Fine grit sandpaper can be used as an alternative to avoid damage to the wallpaper. Finally, install the two-gang wall plate over the extender and the patched area, effectively converting the single-gang opening to a two-gang configuration. Secondly, you could use a drywall ring. Begin by acquiring a drywall ring, which is a metal frame specifically designed to enlarge an existing hole in drywall. Carefully remove the existing nail-up box from the wall. Then, precisely cut the drywall hole to accommodate the larger dimensions of the drywall ring. Install the drywall ring into the enlarged hole using drywall screws, ensuring it is securely fastened to the existing drywall. Insert the two-gang nail-up box into the drywall ring and secure it with screws, completing the conversion process. Thirdly, a plastic flush mount box can be used. Purchase a plastic flush mount box that is designed with two gangs and has similar dimensions to the existing nail-up box. Carefully cut out the existing nail-up box, removing the drywall around it to create a suitable opening for the new box. Insert the flush mount box into the prepared opening and secure it using drywall screws. This method provides a clean and flush appearance, seamlessly integrating the two-gang box into the wall. When dealing with wallpaper, take extra precautions. If possible, carefully cut the wallpaper around the existing nail-up box before starting any work. This will help to minimize damage and make patching easier. When patching or smoothing the drywall, it is important to avoid using spackle or joint compound that could potentially damage the wallpaper. Instead, use a fine grit sandpaper to gently blend the patch with the existing wall surface. If necessary, carefully cut a piece of wallpaper to patch over the repaired area. Apply wallpaper adhesive to secure the patch, ensuring it aligns seamlessly with the surrounding wallpaper pattern. Before commencing any electrical work, always turn off the power to the circuit to ensure safety. Wear safety glasses and gloves throughout the entire process to protect yourself from potential hazards. Exercise caution when cutting drywall and wallpaper to prevent any damage to the wall. Ensure that the new box is level and securely installed to provide a professional and functional result. When working with electrical wiring, it is crucial to adhere to the National Electrical Code, or NEC, to ensure safety and compliance. The NEC provides guidelines and regulations for electrical installations, including wire sizing, overcurrent protection, grounding, and wiring methods. It is important to consult the latest edition of the NEC and any applicable local codes to ensure that all electrical work is performed in accordance with these standards. Wire sizing is a critical aspect of electrical installations as it determines the ampacity or current carrying capacity of the conductors. The NEC specifies the allowable ampacities for different types of conductors based on their size, insulation, and temperature rating. When selecting the appropriate wire size, it is essential to consider the load requirements of the circuit, the ambient temperature, and any dirting factors that may apply. Overcurrent protection is another essential safety feature in electrical systems. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC requires that overcurrent protective devices be selected and installed in accordance with their interrupting rating and ampacity rating. Grounding is a critical safety measure that helps to prevent electrical shock hazards. The NEC requires that all electrical systems be properly grounded to provide a low impedance path for fault currents to return to the source. Grounding also helps to stabilize voltage and reduce electrical noise. Wiring methods refer to the techniques and materials used to install electrical conductors. The NEC specifies various wiring methods, including conduit, cable, and raceway systems. Each wiring method has its own advantages and limitations, and the selection of the appropriate wiring method depends on the specific application and environmental conditions. Ensuring the proper installation of electrical boxes is also a crucial aspect of electrical work. Electrical boxes provide a safe and secure enclosure for wiring connections and devices. The NEC specifies the types of boxes that are permitted for different applications and the requirements for box fill, which refers to the number and size of conductors that can be installed in a box. When working with electrical circuits, it is important to understand the concepts of voltage, amperage, and resistance. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Amperage is the rate of flow of electrical current, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. Ohm's law describes the relationship between voltage, amperage, and resistance, stating that voltage equals amperage times resistance. This fundamental principle is essential for understanding and analyzing electrical circuits. In residential electrical systems, common voltage levels include 120 volts and 240 volts. 120-volt circuits are typically used for lighting, small appliances, and general-purpose outlets. 240-volt circuits are typically used for larger appliances, such as electric ranges, clothes dryers, and air conditioners. In commercial and industrial electrical systems, common voltage levels include 208 volts, 277 volts, and 480 volts. These high voltage levels are used to supply power to larger loads and equipment. When working with electrical equipment and components, it is important to understand their voltage and current ratings. The voltage rating indicates the maximum voltage that the equipment can safely handle, while the current rating indicates the maximum current that the equipment can safely carry. Exceeding these ratings can lead to equipment failure, overheating, and potential hazards. In addition to the NEC, there are other relevant standards and regulations that may apply to electrical installations, such as those published by the National Electrical Manufacturers Association, or NERMA, Underwriters Laboratories, or UL, and the Institute of Electrical and Electronics Engineers, or IE. These organizations develop standards for electrical equipment, components, and systems, ensuring their safety and performance. Adhering to these standards and regulations is essential for ensuring the safety and reliability of electrical installations. When working with electrical systems, it is important to have a thorough understanding of electrical safety practices. Always to energize circuits before working on them, and use appropriate personal protective equipment, or PP, such as insulated gloves, safety glasses, and arc flash-rated clothing. Follow lockout-tagout procedures to prevent accidental energization of circuits during maintenance and repair work. Be aware of potential hazards, such as exposed wires, damaged insulation, and wet environment. Never work on electrical systems when you are tired, distracted, or under the influence of drugs or alcohol. If you are not comfortable or qualified to perform electrical work, it is best to hire a licensed electrician to do the job. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. When working with electrical boxes, it is important to select the appropriate type and size for the application. Electrical boxes are available in various materials, including metal, plastic, and fiberglass. Metal boxes are typically used for conduit systems, while plastic boxes are commonly used for non-metallic cable systems. Fiberglass boxes are often used in corrosive environments. The size of the electrical box is determined by the number and size of conductors and devices that will be installed in the box. The NEC specifies the minimum box fill requirements for different types of boxes and conductors. It is important to select a box that is large enough to accommodate all of the wiring and devices without overcrowding or damaging the conductors. When installing electrical boxes, it is important to ensure that they are securely mounted to the wall or ceiling. Use appropriate fasteners, such as screws, nails, or anchors, to attach the box to the supporting structure. Ensure that the box is level and flush with the finished surface of the wall or ceiling. When running wires into electrical boxes, It is important to use appropriate cable connectors or clamps to secure the wires to the box. Cable connectors and clamps prevent the wires from being pulled out of the box and protect the insulation from damage. Ensure that the connectors and clamps are properly sized for the type and size of cable being used. When making wiring connections inside electrical boxes, it is important to use appropriate wiring methods and connectors. Use wire nuts, terminal blocks, or other approved connectors to join wires together. Ensure that the connections are tight and secure, and that the insulation is properly stripped and protected. When installing devices such as switches, outlets, and dimmers in electrical boxes, it is important to follow the manufacturer's instructions. Ensure that the devices are properly wired and securely mounted to the box. Use appropriate screws to attach the devices to the box, and avoid over-tightening the screws, which can damage the devices. When completing the electrical installation, it is important to test the circuits to ensure that they are properly wired and functioning correctly. Use a multimeter or other testing device to check for voltage, continuity, and ground faults. If you find any problems, troubleshoot the circuits and make any necessary corrections. When working with wallpaper, it is important to take extra precautions to avoid damaging the wallpaper. Use sharp tools, such as utility knives or razor blades, to cut the wallpaper cleanly and precisely. Avoid tearing or ripping the wallpaper, which can damage the surface and create unsightly edges. When patching wallpaper, use a wallpaper adhesive that is compatible with the type of wallpaper being used. Apply the adhesive evenly and smoothly, and avoid getting adhesive on the surrounding wallpaper. Use a seam roller or smoothing tool to press the patch firmly into place and remove any air bubbles. When cleaning wallpaper, use a mild detergent and a soft cloth or sponge. Avoid using abrasive cleaners or scrubbing too hard, which can damage the wallpaper. When removing wallpaper, use a wallpaper steamer or chemical stripper to loosen the adhesive. Carefully peel off the wallpaper, starting at a corner or seam. Avoid tearing or ripping the wallpaper, which can damage the wall surface. After removing the wallpaper, clean the wall surface with a damp sponge to remove any residual adhesive. When painting over wallpaper, use a primer that is designed for use over wallpaper. The primer will help to seal the wallpaper and prevent the paint from peeling or blistering. Apply the primer evenly and smoothly, and allow it to dry completely before applying the paint. When selecting electrical boxes, consider the environment in which they will be installed. For damp or wet locations, use weatherproof or watertight boxes and fittings. For corrosive environments, use boxes and fittings made of corrosion-resistant materials such as stainless steel or fiberglass. For hazardous locations, use explosion-proof boxes and fittings that are designed to contain any potential explosions. When selecting wiring methods, consider the type of building construction and the specific requirements of the application. For concealed wiring, use non-metallic sheath cable or NM cable or armored cable or AC cable, which are commonly used in residential construction. For exposed wiring, use conduit, which provides mechanical protection for the wires. For underground wiring, use underground feeder or off cable, which is designed to withstand moisture and corrosion. When selecting overcurrent protective devices, consider the ampacity rating of the conductors and the load requirements of the circuit. Use circuit breakers or fuses that are sized to protect the conductors from overloads and short circuits. Ensure that the overcurrent protective devices are properly labeled and readily accessible. When grounding electrical systems, use grounding electrodes such as ground rods or ground plates to establish a connection to the earth. Connect the grounding electrodes to the grounding busbar in the electrical panel using grounding conductors. Ensure that the grounding system is properly sized and installed in accordance with the NEC. When working with electrical equipment, follow the manufacturer's instructions for installation, operation, and maintenance. Regularly inspect electrical equipment for signs of wear, damage, or corrosion. Replace any damaged or worn equipment immediately. Keep electrical equipment clean and free of dust, dirt, and moisture. Schedule regular maintenance and testing of electrical equipment to ensure that it is operating safely and reliably. When troubleshooting electrical problems, use a systematic approach to identify the cause of the problem. Start by checking the power supply and the circuit breakers or fuses. Then check the wiring connections and the devices in the circuit. Use a multimeter or other testing device to measure voltage, current, and resistance. Consult electrical schematics and diagrams to help you understand the circuit and identify potential problems. If you are not able to identify or resolve the problem, consult a licensed electrician. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Always to energize circuits before working on them and use appropriate personal protective equipment. Follow the NEC and other applicable codes and standards. If you are not comfortable or qualified to perform electrical work, hire a licensed electrician to do the job. Ensuring the safety and reliability of electrical systems is essential for protecting people and property from electrical hazards. By following proper electrical safety practices and adhering to applicable codes and standards, you can help to prevent electrical accidents and ensure that electrical systems operate safely and efficiently. In addition to the topics already covered, it's worth discussing surge protection and arc fault circuit interrupters, or SIs. Surge protection devices, or SPDs, protect electrical equipment from voltage spikes or surges which can damage sensitive electronic components. SPD are typically installed at the main electrical panel and at individual circuits to provide comprehensive surge protection. SIs are circuit breakers that are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. SIs are required in many areas of the home, such as bedrooms, living rooms, and dining rooms, to provide added protection against electrical fires. Proper wiring and grounding are also essential for ensuring the safety of electrical systems. Wires must be properly sized for the load they are carrying and must be protected from damage. Grounding provides a path for fault currents to flow back to the source, which helps to prevent electrical shock hazards. All electrical equipment and appliances must be properly grounded in accordance with the NEC. Regular inspections and maintenance are crucial for keeping electrical systems in good working order. Electrical systems should be inspected regularly for signs of wear, damage, or corrosion. Any problem should be repaired promptly by a qualified electrician. Electrical equipment should be cleaned and maintained in accordance with the manufacturer's instructions. Education and awareness are also important for promoting electrical safety. Homeowners and tenants should be educated about electrical hazards and how to prevent them. Children should be taught about the dangers of electricity and how to avoid electrical shock. By promoting electrical safety education and awareness, we can help to prevent electrical accidents and save lives. When working with electrical systems, it's important to understand the different types of wiring methods that are available. Common wiring methods include non-metallic sheath cable or NM cable, conduit, and cable tray. NM cable is a flexible cable that is commonly used in residential wiring. Conduit is a rigid or flexible metal or plastic tube that is used to protect wires. Cable tray is a metal or plastic structure that is used to support and route cables in commercial and industrial applications. The choice of wiring method depends on the specific application and the requirements of the NEC. When installing electrical boxes, it's important to choose the right type and size of box for the application. Electrical boxes are available in various materials, including metal, plastic, and fiberglass. The size of the box depends on the number and size of wires that will be installed in the box. The NEC specifies the minimum box fill requirements for different types of boxes. When making wiring connections, it's important to use the proper tools and techniques. Wires must be stripped properly and connected securely to terminals or connectors. Wire nuts, terminal blocks, and crimp connectors are commonly used to make wiring connections. The NEC specifies the types of connectors that are permitted for different applications. When working with electrical equipment, it's important to follow the manufacturer's instructions for installation, operation, and maintenance. Electrical equipment must be properly grounded and protected from overload and short circuits. Regular inspections and maintenance can help to prevent electrical problems and extend the life of electrical equipment. When troubleshooting electrical problems, it's important to have a good understanding of electrical circuits and how they work. A multimeter is a useful tool for measuring voltage, current, and resistance in electrical circuits. Electrical schematics and diagrams can help to identify the components and connections in a circuit. The NEC provides guidance on how to troubleshoot electrical problems and how to make repairs safely. Finally, remember that electrical safety is everyone's responsibility. By following proper electrical safety practices and adhering to the NEC, we can all help to prevent electrical accidents and ensure the safety of ourselves and others.